So far, your reliability has been based on series or parallel system. But we'll just take one quick example on system which are neither series nor parallel. The hope is that at the end of the day, you'll be able to treat such system. So usually, this formula simplifies it. That you have to take it slow. The reliability of such a system is given by you take the reliability across a particular component, right? And you find the probability that the system works if that component is for 3 plus 1 minus um, the reliability that the system works if the probability is 40. If the system is 40. So, for instance, if you were asked to solve this one, to eliminate elements, right, to simplify the diagram. And one thing you can do is that you try to eliminate C. So you try to take the reliability about point C, right? Now, it means that your R of I will be what? R of C. This R of I you see here in the formula will be R of C because you are taking the moment or the reliability about that, right? Now, once you do that, right, you have to consider two scenarios, right? If you are taking the reliability about C, one scenario is that is C working, and the other scenario is that when C is not working. Okay, so when C is working, right, then this block here will be represented by just a short circuit, right? So you realize that when C is working, represented by a short circuit, and that's what you see, right? Short means that it's like constant 1. Now, when C is not working, here will be represented by an open circuit. Right, let me use a different color. So it's represented by an open circuit. Right. Now when it's represented by an open circuit, you realize that now the flow of the function moves from A, right. Now since here is represented as an open circuit, it doesn't move there. Right. So it moves from A through D, right, then to F. Also the upward side moves through B, through E, then towards F. So you realize that at the end of the day, B and E will be in series, right? And A and D will be in what? Series as well. However, both of them will be in parallel with each other. So that's what I'm talking about, right? So you realize that A and D will be in series. B and E will also be in series. However, both of them will be in parallel with each other. And I mean, F was already in series with the whole system, so we can't touch it, right? Now, this is for only one side where C is assumed not to be working. There is the flip side where C is assumed to be working, right? And that flip side is this, right? When C is assumed to be working, then you can only represent it here by what? A short, right? Now, once you do that, then you'd have to solve the other trouble. You see, when you do that, the system was not said to be bidirectional, right? If it was said to be bidirectional, then there is a trick. You can redraw this diagram like A and B, like B here, A here, right? And they will be in series with a parallel combination of what? E and D, then F, right? If you were told that the system was bidirectional, right, it means that certain parts are allowed. But this one, the system is, they do not state it right. So you have to assume unidirectional, right? Now, if you assume unidirectional, you can't assume that A and B are in parallel because if you say A and B are in parallel, then what you are essentially saying is that what you are trying to imply is that the function can flow from B here, go back to A, right? But that doesn't happen. You see, at this point, right, in this diagram, let me use this diagram to explain. These two are said, the top one and the down one are said to be in parallel because at the end of the day, right, when you consider a unidirectional flow, they meet at one point, right? The function flows through them and meet at one point. However, when you consider B and A here, you can't see that. You see, when you consider unidirectional flow, right, it meets at this point. When you consider unidirectional flow for A, it was split up at here, right? So although they meet here, part of A splits, right? So you can't assume them to be what in parallel, right? It's quite complicated when they are not unidirectional, but that's it. So your only choice is that to re-simplify the diagram again, right? So you realize that here for C not working, you have a simple diagram, right? Which you have done, which when you can find the reliability of this, right? And they found the reliability of this as this expression, right? I mean 1 minus C multiplying. Now when you find the reliability of the diagram here, right? That's what you see here. So that one is quite easy. There was no need to fret. But this one is quite tricky because of the fact that we can't assume them to be just in parallel. So we have to take our time, right? Now we have to go through the whole procedure again. We have to start taking reliability about point E, right? Because when we see that when we remove point E, most of our system can be assumed to be in series or in parallel. You get it? So when you remove point E, right, assuming that point E is not working, you come and get this diagram. You come and get a B, and you come and get an A, right? And from the A, you have tab D, D, and that D goes into what? An F as your output. Now, this is for when E is not working. So we realize that when E is not working, then here B comes, but it cannot go back because you are seeing what it is unidirectional. So you don't flow back. You can only flow forward. So since B does not have any relationship to the output, right, we can ignore B for this diagram, right? However, for A, realize that we can trace a path from the input through D through F, right? So it means that these three will be in what? Series, right? When E is not working. And that's the formula you have here. So you realize that when E is not working, you have this formula, A, D, and F, right? Now, you have to come and find for the flip side when E is working. So you realize that when E is working, then your reliability diagram changes, right? So this time you have to draw this. You have to draw B, you have to draw A, and you have to show E as it was short because it's working. You also have to show F, and you have to show D, right? D comes from here to here. So this is D. Now, two things you have to take note of. Remember, because we have realized that I mean when you look at this diagram carefully, you realize that D is not connected across anything, right? It's not connected across anything. So essentially it's like a node connected to itself. So you can remove it from the diagram because it's not connected across anything. So when you remove it from the diagram, then you end up with something like this, right? And now this is a system you can solve. B is in parallel with A, which is in series with F. So realize that you get this, right? As is shown here, that B is in parallel with A, which is in series with F, right? Now, this is what makes it a bit confusing, but don't worry. You realize that our original formula was reliability of C times probability that the system was given that C is for 3 plus 1 minus reliability of C times probability of the system works, given that what C is what 40. Right? Realize that when C was 40, this was the function we got. Right? You can quickly go back and solve again. You realize I get the same thing. Now, this one was already multiplying 1 minus R of C. I mean, according to the original formula, that's what you are supposed to do. The second part is reliability of C times the probability of the system works when it is fault-free. However, remember that this one was made up of two parts. We have to split the problem into two parts for E. One for E when the system is working and one for E when the system is faulty, right? Because we couldn't solve it for the original part. So you realize that the one for E when the system was working, when E was working, we had this, right? Now the one for E when the E was not working, right? We had this, right? So these two will become the probability of the system when what C is fault-free now, right? Now we come and put them back into the original formula here, right? We come and put them back here. And putting it back here, that's what you see here. So realize that we are putting just this one back here. And don't worry if you are seeing a different expression here. This one, the internal term has been expanded. So the expansion of here is what you see here. So don't worry. And that's what you see. Plus, remember that the formula has two parts. When C is working and when C is not working. So you have two main terms, but within the subterm, you also have another two main terms, right? And now this is for the series parallel. It's probably dicey with the whole drawing thing, but it's actually not too complicated. The only complication comes when you have to simplify and simplify again. You may lose track of where you are, right? So I think this should be enough. Yeah, so thank you.